So, when you're typing logs into your calculator, it's actually doing math every single time. What math is it doing? It's saying, if you have log base 2 of 2, it's saying 2 to what power? What exponent is 2? 1. Because in this spot of my board, it's not happy. It's just been doing that.
For like all of the years?
No, like a week. It does what it wants. So, 2 to what power is 4? 2. 2 to what power is 8? Okay, we'll go back. We'll go through these rest in a second. But what if I gave you like 2 to 5? 2 point, not 5. Something. But we do know.
That's illegal.
Yeah, it is illegal because it's 2 point something. So I can't do this one in my head. Correct? That's the point. So that's why you're going to need your calculator for it. But you should know if it's kind of actually accurate when you punch it into your calculator. Like if you go log base 2 of 5 and you get like 20 decimal something, you should be like, I typed this in wrong, because that doesn't make any sense. It should be a little more than 2, because 2 to the 4 is, or 2 to the 2 is 4. Okay, 2 to the what power is 16? 4. 2 to the what power is 32? 5. 2 to the what power is 64? 2 to the what power is 128? I think you've caught the pattern. Okay, so log laws. If I go 4 to the 2, or 4 base 2 of 4 plus log base 2 of, I don't know what I'm saying. Log base 2 of 4 plus log base 2 of 8. Log base 2 of 4 is what? 2 plus log base 2 of 8 is 3, and I get my answer of 5. Correct? Now watch this. Log base 2 of 4 times 8. It's log base 2 of 32, which is 5. Same answer.
No way.
Okay, you're welcome. You're invited, and now you must. Shh. All right. Log base 2 of 2. So excited that you're excited about this. Log base 2 of 2 is what? 1. Plus log base 2 of 32 is 5. And then when you add them, you get 6. Then if I go log base 2 of, and now I have a plus sign in between, I can actually multiply these and put it together. 2 times 32, which is log base 2 of 64, which is 6. You see that? Now, what do all the logs have? Base what? 2. They have base 2, so they have to have the same base in order to put them together. They also have to have 1s in front. If they have a number, we're going to have to use power rule, which we're going to learn later, to fix the problem. Okay? So the connection that you're making here is actually this rule that's on your formula sheet. Log base a of m plus log base a of n, noting that there's 1s in front. Because if there's not 1s in front, I can't do this. So I would draw big 1s to prove a point. If I have log base a of m plus log base a of n, I get log base a of m times n. Whenever my bases are the same, it screams at you, put me together, every time. It should literally scream it like that. You'll hear it in your head. I'm not joking, because you'll say it so many times in your head on the test, it will hear, put me together. It might be my put me together, but it'll still be yours. Okay? So, an example. If I go log base 6 of A plus log base 6 of B minus, oh, can't do that yet, log base 6 of C. I can do 3 of them. Log base 6, log base 6. Log base 6 tells me, put me together. That's what it says. Now I can only put them together if they have 1s in front. Do all these have 1s in front? Yes. So I can put them together by multiplication. So I can go log base 6 of A, B, C. So now the next one I have, oh, and remember that it can work in both directions. So people are often good at putting them together, but forget that they can separate them. So if ever you have like log base 2 of 7 times 9 times 3 times B times C, you could separate them all out with plus signs. You can make 5 logs. Okay? So let's look here. Log base 2 of 15 plus log base 2 of what? Base 2 screams, put me together. So what are we going to do? Yes, it would have been better if it was more of a high pitch put me together, but exactly. That's actually better than that. I'm going to record it and then just play it when I'm done. So, log base 2 of what times what? 15y. Done. Now this one, log base 3, it should have a bracket around it because everything beside a log should always have a bracket. Now this one, I make a point of doing this. I go log base 3 of 9 times x times y. And the reason why I make it so that they have multiplication symbols in between it is that it maybe hints you that you can separate them by additions. Okay? Some people will leave the 9 and the x together if you don't do that. They'll go log base 3 of 9x and then log base 3 of y. But we don't want to do that. We want to go log base 3 of 9 plus log base 3 of x plus log base 3 of y. What's log base 3 of 9? 2, because 3 to what power is 9? 2. So you don't have to type them in your calculator when they're nice like that. And this can be your answer. You want to know why logs are harder? Logs are harder because often you will have a correct answer, but they'll have done something different. So you have a correct answer, it's just not there. So you might have this answer and say it's done. And they might have another answer. Because what they sometimes do is they'll separate them so they can get a nice number like a 2, and then they'll put the ones in the same base back together. So they separate them all, and then they go 2 plus log base 3 of xy. And then that's actually the answer that they have. Do you see that? How they can change it up? That's the hardest part sometimes of logs, is just figuring out how they got the answer on the page that they have, because you have a correct answer, it's just not there. Okay. Shocking, we're going to go to, subtraction. So we have log base 2 of 8 is 3, log base 2 of 4 is 2, 3 minus 2 is 1. What are you guessing is going to happen here? Log base 2 of 8 over 4. Now this is what I want to, so it's log base 2 of 2, which is 1. What I want to show here is it's not that this is division because this is, there's a minus sign in between them. It's division because of this. Watch. If it has a plus 1 in front, what's beside it actually goes in the numerator. If it has a minus 1 in front, what's beside it actually goes in the denominator. So if I went like this, log base 2 of 8 minus log base 2 of 1 minus log base 2 of 2, I could actually go log base 2. They're all base 2, so they scream, put me together. And then this one has a plus 1, this one has a minus 1, this one has a minus 1, so then I say, I can put them together. So I have to go through 2 rules. They have to have the same base, and they have to have 1s in front. Could be minus, could be plus, but they have to be 1s. Now, the 8 has a plus 1 in front, so where is it going to go? The numerator. And then this one has a 1 in front, or minus 1 in front, so where's the 1 going to go? Denominator. It's not going to do anything because 2 to what power is 1? 0. So this actually just goes away. It's a 0, right? Like this whole thing would be 0. I'm going to put a 1 down here anyways. And then this one has a minus 1 in front, so the 2 will go in the bottom. What do I do when I have 2 numbers together? Multiply. So we're actually going to get log base 2 of 4, which is 2. So the key thing to remember with this multiplication and division, and it's lovely that they give you the formulas, but you don't really need them because you just should be able to operate with them, is if they have a plus 1 in front, what's beside them goes in the numerator. If they have a minus 1 in front of them, what's beside them goes in the denominator. And the key thing, too, is that they have to have same base and 1s in front, correct? So some people will say, well, what if they don't all have the same base? Then that's lovely. The ones with the same base can go together, and the ones without the same base can't. That's just it. You can put them all together as a single log if that was the case. So down here's the division law. Log a m minus log a n. It has a plus 1 in front, so the m went to the numerator. It has a minus 1 in front, so the n went to the denominator. So let's look at this one. Log base 2 of 15 minus log base 2 of y. I get log base 2 of 15 over y. And then people have to remember this one. So log base 3 of 9. Always make sure what's beside your logs in a bracket. Minus, because the x is in the denominator, log base 3 of x. What's log base 3 of 9? 2. These laws are used just by themselves. in questions, but we also need these laws to be able to solve exponents that are exponential equations that we can't make common base. You know, when we have two exponents and two bases, we've done that before with exponents. We've only ever solved ones that we can make common base so far. So if we can't make them common base, we have to use log laws. And solving logs, we have to use log laws. So this is used for just their own type of question, which we're going to do in the next few pages, but it's also used in the next lessons afterwards. So we also have the power law. We need the power law if we don't have plus or minus ones in front. What are we going to do? So here we have, consider 3 log base 3 of 2 to the 5. Now the power law, I'm going to show it down here, is if I have log base a of m to the n, I can actually take the exponent and drop it in front, only if I have the word log. So log base m to the n actually equals n log base a to the m. So these are backward and forward. So I can take the number in front and raise it to the exponent, or I can take the exponent and drop it in front. Okay? But why? Well, let's look through this. So if I look at log base 3 of 2 to the 5th, 2 to the 5, I can write that as log base 3 of 2 times 2 times 2 times 2 times 2, correct? Because that's what 2 to the 5 is. And whenever you have things that are multiplied, you can separate them by plus 1 logs, right? So log base 3, 2 times 2 times 2 times 2 times 2, I can make all separate logs. Plus 1 log base 3 of 2, 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 plus 1 log base 3 of 2. Now how many log base 3 of 2's do I have? 5. So since there are 5 of them, I can say I have 5 log base 3 of 2's. Can't I? Therefore, log base 3 of 2 to the 5 is equivalent to 5 log base 3 to the 2. That's why the power rule works. That's why you can take this exponent and drop it in front. Or take it in front and drop it up as the exponent. And it works in both directions. Sometimes you need the number in front, and sometimes you need the numbers of the exponent. And it depends on the question as to where you need it. So this one we have log base 3 of 9 squared. It can be written as 2 log base 3 of 9. And the only reason why I would do that is because 3 to the 9 is easier to do than 3 to the 81, but it's going to get you the same answer anyways. So 3 to the 9, 3 to what power is 9? 2. So it's going to be 2 times 2, which is 4. Showing it this way, it would be log base 3 of 81, which is 4. Because 3 to what power is 81? 4. So it actually works out. Now this one has variables. K log base 2 of a can be written as what? Log base 2 of a to the k. The k is in the bracket with the a, just so you know. So it just goes to the product rule and the division and multiplication laws. Shows them for you, which reiterates them. Then we go to the next page. So, what is the square root of 27 as an exponent? 27 to the what? 1/2. So we get log base 3 of 27 to the 1/2. Remember that your square root is to the 1/2 because what's the index on a square root symbol? So say I do x. What's the index on this thing? What's the exponent on the x? I just drop it underneath. So I get x to the 1/2. You taught in grade 10, right? Or you were taught a couple weeks ago. Either way, you know it. You were taught in grade 10, maybe you don't remember it. It was a rough grade 10. It was the best of times, it was the worst of times. All right. So now I can actually take that 1/2 and drop it in front, because I don't know what 3 to the what power is 27 to the 1/2. I can't do that, correct? But if I take the 1/2 and drop it in front, I do know 3 to what power is 27. What's that going to be? 3. So I actually get 1/2 times 3, which is 3/2. Number 2, I have log base 2. Log base 2, it screams, put me together. So then I try and put it together, but what's the problem? No 1's in front. I have a 1/2 in front and a 1/3 in front. So how can I get those to go away so I have 1's in front?
Log base 2, 6, 1/3 power 1.
Yes, I can bring the exponents up. I always leave the sign and just take the number. What are you asking? So like I don't take negative 1/3 up. Okay, what are you asking?
So if the group has the root 27 is 27 and a half, would it be better to do like 16 and a half rather than 16?
It doesn't matter. I always leave them as halves because I know that's root 16. And when you go into calculus, you're going to need halves instead of roots. So I just keep you guys practicing it. And then this is log base 2 of 8 to the third. Which these are actually numbers. This is the square root of 16. What's that? Square root of 16 is 4. Minus log base 2. Do you see I didn't take the minus sign with? And this is the cube root of 8, which is 2. And then I can put them together because they have ones in front and base 2. So I get log base 2. And then the 4 goes in the numerator because there's a plus 1 in front. And the 2 goes in the denominator because there's a minus 1 in front. So I get log base 2 of 2, which is 1. You're trying 3 to 5. Go. We're going to go log base 2 of x plus log base 2 of 2x minus log base 2 of x squared minus log base 2 of y. And I can put them together. So I get log base 2. X goes in the numerator times 2x goes in the numerator. X squared goes in the denominator times y. What's x times 2x? 2x squared. The x squareds cancel. And I get log base 2 of 2 over y. Now, just so you know, I'm probably not going to stop here. Yeah. And I'm subtracting. Whatever has a negative 1 in front just goes to the denominator. And then you make them join by multiplication. Yeah. Yeah.
Couldn't you split those up and say log 2, like log base of 2 minus...
Yes, which is what they're going to want you to do. So you could stop here, but the answer is probably not going to be there. The reason why they're going to expand it again is now you have a 2 to the 2. So they're going to go log base 2 of 2 minus log base 2 of y. And log base 2 of 2 is 1. Now, which is better? The one that matches the multiple choice. That's it. None of those is better. If they say simplify, though, you technically could simplify, so you keep going to where we're at. This one has a 1, a 1, a 1, a 1, a base 2, a base 2, a base 2, a base 2, so I can put them together. I go log base 2. 2 goes in the numerator. 3 goes in the numerator because there's a plus 1. They get multiplied. 6 goes in the denominator because there's a minus 1. 8 goes in the denominator because there's a minus 1. So I get log base 2 of 6 over 48, which is log base 2 of 1/8. 1/8 can be rewritten as what?
Well, 8 over.
8 to the negative 1 or 2 to the negative 3. Yeah. Because whenever you have it over in a fraction, you can raise to the power of negative 1. So if 8 is 2 to the 3, 1/8 is 2 to the negative 3. Let me show you a different color here. So I can get log base 2 of 2 to the negative 3. Yeah, because your answer is just negative 3. Because 2 to what power, or 2 to what exponent is 2 to the negative 3? Negative 3. So whenever you have this base and this base are the same, your answer is the exponent. So it's log 2 to the negative 3, your answer is just negative. Then this one I have to raise the half up and the 3 up. So you're going to get log base, and this is what I do. 10, 10, 10. And the reason why I write the base 10 is me doing the action of writing 3 base 10s screams put me together in my head. If I don't have the base 10, some people will sit there for a life and not put them together. Why is the button? When a log does not have a base, it is a base 10. Just like when there's a square root symbol, what's the index if there's no number? It's a 2. When a log doesn't have a base, it is base 10. The reason why is most word problems are base 10 logs. So they picked that one to be the common one. It's the same thing with square roots. Most things we do in life are square roots, right? So the index they picked to not have to write is a square root. But a cube root, fourth root, fifth root, half root, whatever it may be, you have to write the number on the index, correct? But a square root, you don't have to. So logs, when you don't have a base, it is base 10 because most word problems and things we do in life are base 10 logs. So if it doesn't have a base, put a 10. Yo.
What's the log song? Do you know the log song?
No.
My mom played it for me.
Oh.
It would make more sense there.
What is the log song?
It talks about how a log has, the standard base of 10 and how the bracket beside it is called the argument. But it's all musical and pretty. I think it'd be necessary.
Okay, well, we'll keep that in mind. Yeah. Log base 10 of A times B3 divided by C to the half. And so often they will write this as log AB cubed, and sometimes they'll write it as the square root of C after. Which one's better? The one that matches. That's it. You're often going to hear that from me. Which one's better? The one that matches. That's it. So that's the hardest part with logs, is you may have a correct answer, it just might not be there. So you have to figure out how you can make your answer be there. We're going past that one. Flipping over. Okay. Now, what base is this one? 10. What can we do? Expand. It even tells you. Okay. So we're going to get log base 10 of 100 plus log base 10 of A plus log base 10 of B squared. And so you're going to get, what is log base 10 to 100? 2. And then we can put them together. Log base 10 of AB squared. Do I need the base 10 on that log though? No. But I tell you that if you write the base 10s always when there's no base, it will give you better hints. Because if you have to convert from a log to an exponential, you're going to need a base. If you put them all as base 10 by the third base 10, you're like, wait a second, these are all the same. Put me together, is what it'll scream at you. Okay? All right. Number 1, 2, 3. Try out. 1, 2, 3. Now we're going to go to a little bit more advanced questions. 1, 2, 3.
Just what is A when A is 100? What is the okay,
So for 1, you should have gotten C. Log base 5 of 25. 5 to what power is 25? That's why I told you I put dots in between, or else you're going to make the 25 and the M cube join.
I was trying to solve A, B, C, and D like the.
That's true. Okay, number 2. We have log base A of the B root of A. How could I write that out? Log base A of A to the 1B, 1 over B. And what could I do with the 1 over B? I could drop it in front, or I could say a to the 1 over b is 1 over b. Either way you do it. So we can move the 1 over b to the front if that doesn't make any sense. The log a to the 1 over b, the exponent is always the answer. You could go 1 over b, bracket log a to the a. And what's log a to the a? Just 1. So it's still 1 over b. Same answer. C, the expression 3 log base x of 4 plus log base x of 8 minus 1/4 log base x of 16. Base x, base x, base x. Screams, put me together. So we get log base x of 4 cubed plus log base x of 8. And the reason why they're going to put the base x is because if they put the base x, you can't just plug these into your calculator. Like if they're base 2s with a 3 beside, you could just plug it in and get an answer, right? And absolutely no loss. So if they put it as a base x, you actually have to know what you're doing. Log base x of 16 to the quarter. So we would get log base x of 4 cubed, or 64, doesn't matter, times 8 divided by 16 to the quarter. And which one do you get? See? Number 4, I'm going to Elsa it. Well, you'll find out.
Whoa.
I thought you had to read
Because I waited for this very moment.
this. I was paying attention so much.
All right. I Elsa'd it because everyone forgets how to do these ones. This bright light is so awesome. I wish it was here all day long. Okay. So, people will separate this one, and they will go do this. They'll go log base a of 75 plus log base a of to the 2. They'll write that out, and then they'll go, okay, log base a of 5. Log base a is 3. I don't have a 5 or a 3. How do I get an answer? That's what they'll do. So, when you have log base a of 75 and I can't get an answer, but I can get an answer for log base a of 5 and log base a of 3, if I could split this 75 up into 5s and 3s, I would be good. So, what is 75 in 5s and 3s? 5 times 5 times 3. So we get log base a of 5 times 5 times 3 times a squared. Because 5 times 5 times 3 is 75. And although 75 is lovely, it doesn't have an option there to pick. So we know that when we have multiplications, we can separate them out by addition. So we can go log base a of 5 plus log base a of 5 plus log base a of 3 plus log base a of a squared. Now we know log base a of 5 is just equal to 7. So I can go 7 plus log base a is 8. And then what's log base a of a to the 2? 2. When your base and what's beside are the same, your answer is the exponent. If you don't remember that, you drop the 2 in front. It's 2 times 1, which is still 2. And so I get 24. These ones are leading into solving logs. So this is what I told you to do. If they don't have bases, put base 10. And by the time you write the second base 10, hopefully it's screaming, put me together. Okay? Because when your bases are the same, that is what they're trying to get you to do. They're trying to get you to put logs together. That's it. So the moment you write base 10 and then write your second base 10, be like, ooh, I know what to do. Okay? So I'm going to get log base 10. And now this one has a plus 1 in front, so x goes in my numerator. This one has a plus 1 in front, so x plus 4 also goes in my numerator. And when there's two things in my numerator, they get multiplied. So I'm going to get log base 10 of x squared plus 4x, which is b.
We're multiplying what?
Oh,
The thing by the
no,
thing.
no, I'm sorry.
No, you multiply.
You multiply what's beside the logs.
Which one are we doing?
5.
5.
No, but like,
x and x to the 4, x plus 4. You're just multiplying what's beside the logs together.
Okay.
For 6, shh, please pay attention. Stop talking. For 6, this is base 10, this is base 10, and I'm hoping by the time you write the second base 10, it screams, put me together, right? That's what you have to see. When the bases are the same, it literally is screaming that to you, but it's not. But we hope that with enough screaming, it just happens in your head. You hear, put me together, every time. So, how can I put them together? They have to have a +1 or a -1 in front. And do they? Yes. So I'm going to get log base 10. And in my numerator, I'm going to get x squared minus 4. And in my denominator, I'm going to get x minus 2, which is not an option. What else can I do, though? Yeah, so I can drop off the base 10 if I want to. It doesn't matter. I put it there so that you don't try and put something else in it. I find that if you don't have a base 10, you guys will try and slide something else into that base. So there must be something there. So if I put a base 10, then you don't actually slide stuff into it by accident. So we get x minus 2. I did not leave enough room. X plus 2 over x minus 2. And then these cancel, so I'm left with log x plus 2. Your homework, and you need to do these, like, tonight. Because we need these log laws forever. So this is the only thing that's going to be on your homework for this week. Just this homework. Just this homework. I'm even telling you to be quiet. Just this homework. Okay. That's good. You should have. That's helpful for yourself. You should do the homework without me checking it. That's how everyone should do, because that's real life. So you're okay. It's just there's other people who do the homework. So. Write these down. Write those down.